Hey, it's Dr. J. We're going to finish Chapter 3 today. This will be the grand finale of 3.7. I'm just going to talk a little vocabulary today. So I've got this whole problem set up for you. All the graphs in this problem are provided for you. I want you to find the largest possible domain on which the function is one-to-one. Yeah, so obviously none of these functions are one-to-one. You might recognize them all. They're all parabolas. Parabolas are classically non-one-to-one unless you restrict the domain. And so we have these two different terminologies. We have non-increasing and we have non-decreasing. So just a quick refresher. Non-increasing means decreasing plus the vertex. Yeah, we want the x-coordinate. Coord, C-O-O-R-D is the abbreviation for coordinate. Okay. And the reason why is because decreasing ordinarily, if you review back the increasing, decreasing terminology, decreasing does not typically include the vertex. So it would be an open interval. So we want this to be a closed interval on one side. So one of the sides of the inequality, or of the domain is essentially an inequality, will be closed. All right, and then now you got to just look at the graph and look carefully which side is the increasing side and which side is the decreasing side. Remember, the left-hand side of the graph does not go in the direction that you might think. It kind of looks like this graph is going up, but that's the left side of the graph. So this side is actually coming down. This is the decreasing side. All right, I'm just going to say DEC for decreasing. I know it looks like December, but it's decreasing. On the other side of the graph, it's increasing. It's going up. INC for increasing. All right. So we want the largest possible domain on which this function is not increasing. Yeah, non-increasing. So we want to throw away this half of the graph. Yeah. And we're going to keep this half of the graph. Yeah, so I'm just going to go ahead and use my finger. So I'm going to delete this whole side of the graph. So now the function is one-to-one. You see? It's just a half parabola, including the vertex. The vertex is at -2. That's the x-coordinate of the vertex. So the answer to this one is -∞ to -2. So that would be the domain on which this function is non-increasing. All right. Similarly, let's go over here to part B. That's supposed to be a B. If you can read that, it looks like a 6. So this is part B. All right. Remember, the left-hand arrow looks like it's going down, but it's not really going down. It's actually coming up. So this is a little refresher from the previous sections where we're talking about increasing and decreasing. So this side is increasing now. And then the right side is truly going down. That is a decreasing function. It's going down. So we're still in this category, non-increasing. So non-increasing means throw out this side. Or you could say delete this side and keep this side. Keep the decreasing side. All right. So we're going to keep this side of the graph here. And then we're going to delete this side. Just erase it or cross it out. And make sure you keep the vertex. Don't toss out the vertex. Keep the vertex. So you're going to keep the decreasing side and the vertex. So your domain is going to go from the x coordinate. Be careful. Yeah. It looks like 4, but the x coordinate is 0 at this point here. Yeah. Y is 4. But we don't want the y value. We want the x value, the x coordinate. So we want 0 to infinity. So 0 to infinity would be the largest possible domain on which this function is now 1-to-1. If you keep the left-hand side, it won't be 1-to-1. So that's why I erased it. So it's basically a truncated or a restricted function. It cannot go all the way to negative infinity. It can only go towards positive infinity. Okay, so these two graphs are both non-increasing. Very similar logic, non-decreasing. Non-decreasing means increasing plus the x-coordinate of the vertex. Okay. So look at this graph very carefully. Notice I don't put the arrows on it right away because they are not both going up. Only the right-hand arrow goes in the direction that it looks like it's going. The left-hand side of the graph is always opposite. So that looks like it's going up, but it's actually coming down. All right. So my increasing side is the right side, and my decreasing side is the left side. So this time I'm doing non-decreasing. So that means I'm going to keep the increasing plus the vertex. So we're going to keep this side, and we're going to throw out, yeah, I'm actually going to change to the word delete because it's less letters. So I'm going to delete the left-hand side here. So take a good look at it because it's about to go away. Delete. Don't forget to keep the vertex. So the vertex is at 0. All right, we want the x-coordinate of the vertex. So this domain is also from 0 to infinity. That's the largest domain on which this function is not decreasing. One more example, and then we're going to have to draw these graphs ourselves in the next example. So enjoy the honeymoon. It's about to end. Okay. So look at the graph. It looks like both of these arrows are going down, but really the right arrow is going down. Yeah, so that right arrow is decreasing, but the left side is not actually going down. It's actually going up. The left side is increasing. Okay. So what do we want? We want the increasing plus the x-coordinate of the vertex. So we want to keep the increasing, and we want to delete the decreasing. So we're going to delete this side over here. I actually like to see it disappear. So delete. You're gone. You're not 1-to-1. So we are deleting you. Okay. And now we're going to keep everything from negative infinity all the way to the x-coordinate. Yeah, The x coordinate. I don't care about the y coordinate. The y coordinate here is 5. Just like over here, the y coordinate was 4. Yeah, but we want the x coordinate. So that'll be 3. So the answer to part D is negative infinity, comma 3 with a closed bracket. Okay. So that's your vocabulary for increasing, non-increasing, and non-decreasing. Okay. So I'm going to give example 2. I'm going to give you a function, f of x. This is what we call a restricted function, so it's already been restricted. Okay. This might make a little bit more sense if you rewrite the function. I like to get rid of f and just call it y. Okay. And then you have reflection. Yeah, about the x-axis. By multiplying all the y's by -1. Yeah, that negative sign really acts like a -1. And then we have a vertical shift up 5 units. .5, 3.6 review. Doing a lot of review as we move through the last couple sections here. All right. I just want to get an idea of what this looks like before I find the inverse function. Okay. So let's just do a rough graph here. So we have our mother function, x, y, -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4. All right, so the mother function, call that mom. That is your y equals x squared traditional parabola that we've been spending a lot of time with. So we got y equals x squared. So now we're going to multiply all of the y's by -1. And then we're going to add 5 to all the y's. So I'm not even answering the question right now. I'm just trying to get an idea of what this graph looks like. So I'm drawing a graph so that I could see what's going on. If you already know what's going on, you can just do the problem. If you have a good, image in your mind of what the graph looks like. It takes experience. Once you've done 1,000 of these, you can just look at the equation and you'll just know what it looks like by reading it. But right now I'm just taking one step at a time. So I've got 4 times -1 plus 5, that's 1. 1 times negative 1 plus 5, that's 4. 0 times negative 1 plus 5, that's 5. And then notice the last two values always repeat the first two values. That's because it's a parabola. It's symmetric, yeah? It's actually like this, an upside down parabola. All right, so I'm going to draw a graph over here, and then I'll come back over here and finish the problem, okay? So this is what we're actually graphing. And we're restricting our domain to be x is less than or equal to 0. Yeah. So these points are not in the domain. Yeah, because these x values are not less than 0 or equal to 0. So keep all of the x's that are less than or equal to 0. So you got 0, 5, negative 1 and 4, and negative 2 and 1. So there's your graph. It should be a one-to-one function. If it's not one-to-one, we did something wrong. Does that look one-to-one? Yeah, notice it doesn't have another side to it. It's a half parabola. Half parabola is one-to-one. All right, so this is our f. So now you see the graph essentially turns the lights on. Now you know what we're talking about. Okay, let's come back over here and find the inverse function. Okay, so remember the steps. We did these steps yesterday. So you rewrite it, then you switch the x and the y. Then you solve this for y. Okay, so let's go plus y squared plus y squared. So I've got x plus y squared equals 5. Subtract x. So I get y squared is 5 minus x. Or you could write negative x plus 5. I don't particularly care. Either does the computer. It'll take either one of these. And now here's the tricky part. You need to take the square root of both sides. Okay? Now be careful. There are two possibilities. So you have to decide which one you want to keep. So which one of these are we going to keep? Well, it depends on this. If x is less than or equal to 0, you're going to keep the negative. If x is greater than or equal to 0, then you're going to keep the positive. So we're going to keep this one. And we're going to throw out the positive, and we're going to keep the negative. That's based on the original problem. Very important. Okay. Because the square root has two possibilities. It's each plus or minus depends on which side of the domain you're on. Yeah, we're on the left side of the domain. See the left side here? So that's the left. This one would be the right. So we threw out the right side. The right side is gone. All right. So our answer is, I'll write the answer up here, F inverse of x, that becomes the y, is negative the square root of 5 minus x. All right, and then now you want to know the range? Well, the range of F inverse is the same as the domain of F. So that is from negative infinity to 0. That's the range. So if you know the domain of the original F, then you also know the range of the inverse function. There is a slight variable translation that goes on. The domain is x, the range is technically y. So this technically means y is less than or equal to 0. That's what that means. I'll just put that in a little cloud. Essentially looks like this. This would be your F inverse. Okay. So we're going to get more into this example here, this principle here in the next example. When you have an inverse function, these should look like mirror images of each other across this diagonal line. I'm kind of low on space here, so I'm going to move on to the next example. This example is done. So we have the inverse function, and we have its range. Okay. Just FYI, if you're curious, so the range of F inverse was what was asked. Just for your information, in case you're curious, the domain of F inverse is the same as the range of F. So look at your original F function. The range of F is from negative infinity to 5. That's the same as the domain of F inverse. Yeah, see, it goes all the way to 5. Goes from negative infinity all the way over here to 5. Okay, and again, this question didn't ask that, but I thought you might want to see it just to kind of wrap up the whole concept. Okay, we're going to do some more technical graphing, a little bit more detailed than the graph that you have here. So example 3, let f of x be x minus 3 squared. Find the largest possible domain on which f, oh no, come on, there's the eraser, you see it? Come on, back to me. Good. Find the largest possible domain on which f is non-increasing. Actually, I changed my mind. We already did non-increasing. Let's do non-decreasing. I guess we've done both, but for this particular example, I'm going to do non-decreasing. Okay, and then find f inverse of x, and graph both f and f inverse on the same set of axes. Okay, so the graph I'm going to draw right now is only a sketch to get the idea. This graph doesn't count. When I go to do my actual graph, I'm going to use this graphing board here. So we'll just put this to the side, and we'll use that in a minute. Okay, this is just a rough graph, just to get an idea. So we've got x and y. Doing a lot of parabolas today. We'll do even more tomorrow. Remember, the mother function was x squared. Anytime you see squared, you know you're using the x squared mother function. So 4, 1, 0, 1, 4. Which way are we shifting? We're going to shift left. 3 units? No. I was just testing you. Remember, negative means right. Shift right 3 units. That was a trick question. So we're going to go right 3 units. We're going to add 3 to all of the x's. So 3 plus negative 2. That's going to be 1. 3 plus negative 1, that's going to be 2. 3 plus 0, 3 plus 1, and 3 plus 2. The y's didn't change because there's no reflection and there's no vertical shift. So the y's stay exactly the same. Okay. So this is my function. All right. Now, you might say, that's a rough graph? Well, this is a rough graph because I don't really care about much other than the vertex. That's all I really care about. So that's what I mean when I say a rough graph. All right. You get really good at this, you can just read the question and bam, you can draw that rough graph, because I'm actually not grading this graph. This graph is just to give you the idea of which side of the graph are we going to take. Yeah. So we want non-decreasing. So we want to get rid of this side. This side is the decreasing side. This side is the increasing side. And we want non-decreasing, so we are going to throw out or delete, I like that word better. We're going to delete all of this, and we're just going to keep the right-hand side. So the domain will be from 3 to infinity. Yeah, from 3 to infinity. Remember, I want the x-coordinate of the vertex. I don't care about the y-coordinate. The y-coordinate is the range. I want the domain here. So this is now what your graph looks like. It's just half of a parabola starting at 3. X equals 3 and y equals 0. All right. So my comment earlier about if you are really good at graphing, or if you've been, experienced in this process, you can just read this question and bam, you could just jump right to here. My hope is that at some point you can do all of that mentally without having to do all of this. At some point we're going to have to abandon this concept here. It's just too tedious. It takes too long. Okay. All right, keep this. We're going to use it later. Later in the problem. Okay, so we got the domain, check, non-decreasing. Now we're going to find the inverse function. So remember how to find the inverse function. You rewrite it as y equals. You switch the x's and y's. And then you solve this equation for y. Now, I like to move my y onto the left-hand side. So I have my y minus 3 squared on the left and my x on the right. That just makes the rest of the steps a lot easier. OK. I'm going to take the square root of both sides. Now I have a very important choice to make. Which square root do I keep? OK. So I want to keep the positive if it's the right side of the graph. Yeah. X is greater than 3. So that's the right side. Keep the negative if left side of the graph less than 3. So you have to look at your domain. If you kept the right side of the graph, well, then you're going to keep the plus on your square root. If you kept the left side of the graph, then you're going to keep the negative. All right. So clearly, we kept the left side. X is greater than or equal. Sorry, we kept the right side because x is greater than or equal to 3. We deleted the left side. Yeah. So we don't want this. We want this. All right. I'm running out of room. So I've got my f of x here. I'll just write it over here out of the way. So there's my f of x. I've got my inverse function here. Y minus 3 is the square root of x. I kept the positive square root. And I'm going to add 3 to both sides. When you keep the positive square root, you do not need to write it. It's implied that that means the positive square root. It's only if it's negative that you need to actually put the sign. Right? And then we get rid of the y, and we call that f inverse of x. OK. All right, so this was just a rough sketch. I want to draw an accurate graph of both of the functions. So to be a little bit more accurate, I'm going to use this. Let's see if I can get a little bit closer. How's that? It's a little better, huh? Okay, so let me do a little housework here before we move on. So I've got my graphing board here. I've got my original function. Where's my original function? I guess I'll write it over here. F of x is x minus 3 squared. And the table of values was 1, 4, 2, 1, 3, 0, 4, 1, and 5, 4. OK. And then I've got my inverse function. My inverse function's right here. And its table is very simple. You just take your mother function table here, f of x, yeah, and then you reverse the x's and y's. So 1, 4 is going to become 4, 1. 2, 1 is going to become 1, 2. That's what an inverse does. It reverses the x's and y's. 0, 3, 1, 4, and 4, 5. So literally just take this whole chart and flip it over so that the x's are on this side and the y's are on this side. All right, so this is your inverse function table. All right, so let's go ahead and draw these graphs. Let's see, so f, we got 1, 4. 2, 1. And 3, 0. 4, 5. And 5, 4. But remember, x must be greater than or equal to 3. So we are deleting these 2 points. And we're only keeping the right-hand side. So x must be greater than or equal to 3. So we do not want any x's that are less than 3. So this is f. You could just use the letter f for the original function. All right. Well, since we deleted all of the x's that were less than 3, over here, we have to delete all the y's that are less than 3, because for the inverse function, the y's have to be greater than 3. Keep in mind, the x's for your original are the same as the y's for your inverse. So now for my inverse function, I'm putting a dot at 3, 0, 3. That's on the y-axis. Then 1, 4. And then 4, 5. And that is your inverse function. Okay. You'll notice that there's a symmetry. This is the line y equals x. All right. So now we have a neat fun fact. The graphs of f and f inverse are always symmetric about the line y equals x. So if you graph two functions together, one of them's the original f and the other one's the inverse, they will always look like mirror images. I think it might be a little easier to see if you hold the graph like this, where the line goes vertically like that. I know it doesn't really go that way. It actually goes like this. But if you hold your paper like this, you can clearly see that those look like mirror images of each other. The red line should be cutting them right down the middle. That's the line y equals x. Okay. Just for fun, I have the camera zoomed in already, so let's just for fun answer a few questions here. We're done with the question that was asked, but you know me, I'm never going to quit if I have extra time and space, so let's keep going. All right, so domains and ranges. So let's just practice our domains and ranges. So domain of f. F is the blue graph. That would be from 3 to infinity. Range of f, again, the blue graph, 0 to infinity. Yeah, because this value here is 3, 0. Yeah. So that's for the blue one, if you can see that. Now when you do the domain of f inverse and the range of f inverse, you get these answers for free. Just reverse these. The domain of f inverse is going to be the range of f, and vice versa. The range of f inverse is going to be the domain of f. So this is always a buy 2, get 2 free. On the inverse function, the 3 is 0, 3 for this terminal point here. And then for the original function, it was 3, 0. Those are always going to be reversed, the x and y values. Okay. The last thing we're going to talk about is what's called the inverse test. You can actually test to see if something is an inverse. Determine if the pairs of functions are inverses. Okay. So let's do a couple different ones. Let's do f is 2x minus 4. And g is x over 2 plus 4. And for the second one, part B, we'll do f is the cube root of x minus 2. And g of x is x cubed plus 2. So we have a test. We call this the inverse test. If fog is equal to x and goff is equal to x. So we're going to review our fogs and our goffs. If both of these functions are equal to x, then f and g are inverses. All right, so this is our test. We're going to perform the composition, and both ways, Fogg and Goff. If either one of these comes out not to just be one letter, x, then we say no. But if they do both come out to just be x, then we say yes, they are inverses. All right, so let's try this one first. Let's go ahead and test. Fogg of x. Can't see that. If it passes the Fogg test, then we give it the Goff test. So we're going to take f and put g inside of it. So g goes inside of f. That's going to be 2x over 2 plus 8 minus 4, which is x plus 4. So no, stop. Right? It did not equal just x. It equaled x plus 4. If it fails either one of these, stop. There's no need to give it the next test if it fails the first test. You only get one chance to fail. Once you fail, that's it. You don't get a second chance. Okay, so no. These are not inverses. All right. Just pausing so you can write all that down, and we're going to erase this and do these two functions. I've already adjusted my camera. I don't want to readjust it until I'm finished, so you're going to have to deal with the... So now we're going to try part B. So let's test Fogg. All right, test Fogg for these two functions. So we got Fogg, that'll be the cube root of blank minus 2. And we're going to put g inside the blank. So we get x cubed plus 2. And we're hoping, I always hope that they are inverses, but sometimes they're not. You're going to simplify this, get rid of the parentheses, cancel the 2's, and you have the cube root of x cubed. That is just x. So far, it looks like yes. But you can't stop yet. Now you have to do the second test. It has to pass both tests. So if it passes the first test, then give it the second test, the Goff test. The Goff means take g and put f inside of it. It's just the reverse of Fogg, you know? Switch the order. Now we're doing g after f. So f goes inside, g goes outside. The cube and the cube root are going to cancel. The negative 2 and the positive 2 are going to cancel. You got just x, check, check. And so yes, they are inverses. Okay, that's it. That's all the material from chapter 3. So I wish you all the best. I will do one small section of chapter 5. We're going to skip chapter 4 altogether. So we're going to skip chapter 4, and we're going to go on to 5.1 tomorrow. right. The test is on Monday. Okay, Dr. Jordan, signing out.